Hello and welcome to yet another video of Cornerstones of Math. A long time ago, I uploaded this video about finding the certain limit. I'm gonna put the link in the description. The interesting thing about that video was that I didn't use the famous L'Hopital's rule, but instead I showed that the limit can be evaluated using the inequality, aka the squeeze theorem. In this video, we're gonna do the similar thing. We want to find the limit of n to the power of 1 over n as n goes to infinity. To be fair, this limit can be easily evaluated using the L'Hopital's rule on its logarithm. But here, we are going to calculate this limit without using the L'Hopital's rule, not because the other method is faster or something, but just for the intellectual pleasure. We are going to solve this problem in 2 steps. First, we need to prove a certain inequality. More specifically, when x is greater than 1 and n is greater than 1, we will prove that n times x minus 1 is less than x to the power of n minus 1. Next, we are going to use this inequality to find the limit of n to the power of 1 over n. So the first step, proving the inequality. We are going to use the famous differentiation method. Let fx be the function x to the power of n minus 1 minus n times x minus 1, where n is greater than 1. By differentiating, the derivative is given as n times x to the power of n minus 1 minus n, which equals n times x to the power of n minus 1 minus 1. Notice that the derivative is positive when x is greater than 1. Therefore, fx increases when x is greater than 1. This means that when x is greater than 1, fx is greater than f1, which is 0. And fx being greater than 0 proves the given inequality. So how can we use this inequality to find the value of this limit? Well, we can easily notice that n to the power of 1 over n term appears if we substitute x with n to the power of 1 over n. So let's test this value to see where it leads us to. Then we have n times n to the power of 1 over n minus 1 is less than x to the power of n is equal to just n, hence n minus 1. If we divide by n, which is greater than 1, then we have n to the power of 1 over n minus 1 is less than 1 minus 1 over n. And when n is greater than 1, n to the power of 1 over n minus 1 is greater than 0. This gives n to the power of 1 over n is greater than 1 and less than 2 minus 1 over n. However, this inequality right here is problematic because the leftmost part is just constant 1, so it converges to 1 as n goes infinity, but the rightmost part converges to 2 when n goes infinity. That is, we cannot use the squeeze theorem with this inequality. Therefore, we have to go back and try with another value. Now, what if we try x equals n to the power of 1 over 2n? If we plug in this expression, then we have n times n to the power of 1 over 2n minus 1 is less than n to the power of 1/2 minus 1. So we have n to the power of 1 over 2n minus 1 is less than n to the power of 1/2 minus 1 divided by n, and this is also greater than 0. So we have n to the power of 1 over 2n is greater than 1 and less than 1 plus n to the power of 1/2 minus 1 divided by n. But we want n to the power of 1 over n, not n to the power of 1 over 2n. Therefore, we square the entire inequality, which we can totally do since all terms are positive. This gives n to the power of 1 over n is greater than 1 and less than 1 plus n to the power of 1/2 minus 1 over n squared. Here, this limit converges to 1 because this term goes to 0 as the denominator has higher degree. Therefore, by the squeeze theorem, the limit of n to the power of 1 over n as n goes to infinity is 1. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.